For any triangle ABC, if A times cosine squared C over 2 plus C times cosine squared A over 2 equals to 3B over 2, then we need to show that ABC are in arithmetic progression. Okay, let us begin. Now, before proceeding, let's talk about a few terminologies. Let's say we have a triangle ABC. Then the sides opposite to angle A, angle B and angle C are going to be represented by the letters A, B, C in lowercase respectively. If we take the sum of the sides, A, which is A plus B plus C, that's going to give us the perimeter of the triangle ABC. Now, if we take half of that perimeter, that gives us the semi-perimeter, and that's represented by the letter S in lowercase. The reason why we are mentioning the semi-perimeter of a triangle here, because with the help of the semi-perimeter S, we can define the half-angle formula for cosine function. Now we know that cosine of A over 2, so this is given by the square root of S multiplied to S minus A divided by BC. Then cosine of C over 2, this is going to be given by, we'll take the square root, underneath the square root, we'll start with S, the semi-perimeter, multiplied to S minus. Now we'll take the side that is opposite to angle C, which is C itself, divided by the product of the two adjacent sides to angle C. So here we see that the sides that are adjacent to angle C is going to be A and B, so we'll take their product. Now we will use this to value and substitute into a given equation. So here it is given that A times, so A is going to represent the side of the triangle, multiplied to cosine squared C over 2, added to C times cosine squared A over 2, and it's given that this is equals to 3B over 2. Let's use the value. We have A multiplied to, so squaring cosine C over 2 gives us S multiplied to S minus C divided by AB, added to C times squaring cosine of A over 2, we're going to get S multiplied to S minus A divided by BC. So that's going to be equals to 3B over 2. So here we can factor out some common terms from the numerator and the denominator. That's going to leave us with S multiplied to S minus C divided by B, added to S multiplied to S minus A divided by B. That equals 3B over 2. Okay, now we're going to further simplify. Let's take S over B as the common factor and combine the two terms on the left hand side to get S minus C added to S minus A. This will be equals to 3B over 2. Now what is S minus C plus S minus A? So that's going to be 2 times S minus A minus C. However, here we know that A plus B plus C, that's equals to 2 times the semi-perimeter. So that means we can replace this 2S with A plus B plus C, and we have to subtract A and C from it. So subtracting A and C leaves us with B. So that means this entire expression within the parentheses can be replaced with B, so that we get S over B multiplied to B equals to 3B over 2. So let's factor out the B. Now we have 2 times S equals to 3B. So 2 times S, that's simply A plus B plus C. That's equals to 3B. Or in other words, we have B minus A equals to C minus B. So whenever this particular criterion is met, this only tells us that A, B, C, these are the sides of the triangle ABC. These three sides are in arithmetic progression. So hence we have successfully proved the problem. For any triangle ABC, if the given equation is true, then it must be true that ABC are in arithmetic progression.